All right. Let's go ahead and show you how to tackle these problems today. We're going to be talking about our point slope form and how to make an equation for a parallel line. And let's get into it. First, you need to know your point slope form. So, wrong marker here. My bad. Oh, I swear I saw a blue marker. There he is. All right, so point slope form. See if I can fix this camera a little bit nicer. Oh, that's beautiful. All right, so point slope form. Let's go ahead and write what that is right over here. Point slope form looks like y minus y1 equals slope, open parenthesis, x minus x1, close parenthesis. So we're going to be using that today in connection with the equations that we want to make parallel lines of. So parallel lines also have the same slope. They go up at the same rate. That's why they never collide, because they're moving at the same pace. So going forward here, you're going to be given an equation in these problems. Usually you need to push those into y equals mx plus b format. So let's go ahead and make this look like that. All right, so first I'm going to have to get everything, or trying to get y's by itself. So I'll subtract 2x. These guys zero out. I got negative y. That negative 2x stays that, and positive 2 stays that. And then I need to make this whole equation positive, so I'll get rid of that negative sign by dividing by negative 1, and I get y equals 2x minus 2 after dividing each of these guys by negative 1. So here I see my y-intercept is negative 2, and my slope is positive 2. So that'll go up 2 over 1, up 2 over 1, so on and so forth. I'm going to go ahead and make that line. Nice. Not too bad. Okay, and now the one thing that we'd know here, identifying the slope of the original and the new line. The original line has a slope of, and again, our letter m represents that slope, and here's where that number is, where m would be, and so our slope here is going to be 2. And our new line will also have a slope of 2. And again, our new line has a slope of 2, but we're going to use this point here, 5, 4, to make that equation. So to make that equation, we're going to go back up here. I'm going to kind of use this business here. I'm not worried about the y-intercept. That is not important. It is the slope that's important, that 2. And that'll lead us into this equation. So y stays the same, y minus y1. I have x1, y1. So you can see I'm going to sub in here, minus 4 equals my slope. We said is 2. And then x minus x1 is 5. So this may look a little bit crazy right now, but we just need to simplify this equation. We'll first use the distributive property and then move things over. So we have y by itself. So let's go 2 times x is 2x. 2 times a negative 5 is negative 10. And I still have the y minus 4. And lastly, we'll add 4 to each side. And now we have y by itself, 2x minus 6. So this is our new equation, what we did all that work for. And if I plot the points here, my y-intercept is negative 6, up 2 over 1, up 2 over 1. We can see that these lines will never cross. They are parallel. And there we go. And it should go through 5, 4, pretty close, as that's the point that we wanted it to go through. Obviously, I could have a little bit of a error here, not using an exact ruler, and I'm using pens and so on and so forth. But that is the idea, is you're going to be getting the original equation into that y equals mx plus b format. Once you do that, you'll then use your point slope form with the point provided to replace for your x1 and your y1. When you do that, you got to do a little bit of math writing it down, but you will generate a equation that is parallel to the original line.